Hi students. So in my previous video I have said that I will follow some steps while designing such DFA related problems. So and I have also said that these steps will be universal steps. I mean, for all such designing problems I will be following these steps. In my previous video I have designed 3 machines. I have solved one type of designing problems and I have explained all the steps, and in this video I will be solving another type of problems and I will be solving 3 more problems of one type. Okay, so just for recap, these are the steps. Just go through this and remember these steps. I will be following these steps while solving the upcoming problems. Okay, so let's start with the first one. Okay, so today's first question is, we have to design a DFA that will accept all the strings of length equal to 3. So this is basically the condition, and this is how we represent length of a string. Okay, mod symbol, and this is the set of possible input symbols. So you have input symbol A and input symbol B. Now, as you know, we'll follow the same steps like my previous video. So the first step, what does this first step says? We have to think of all the possible strings that satisfy this condition, and those are the only strings that will be accepted by this machine. So my set will look like this, as the length is 3 and we have no restriction on the type of input symbol. So I mean, the possibility of occurrence of both input symbols is actually same or equal. So AAA or AAB or BAB and so on, all the strings having length equal to 3. Okay, so step 1 is over. Now step 2. So we know that in step 2 what we do, we design the machine such that this machine will accept the smallest possible string. Now, as there is no restriction on the type of input symbol or the input symbol, only the constraint is the length. So let's start with the initial state. So this is my initial state, and whatever be the type of input symbol will make a transition from Q0 to Q1. Now a very important point, very important. Okay, so whenever we are in Q1, it means we have got a string and we have traversed length. So now a very important point, that is, when we are present in this state, Q1 state, this means we have traversed length 1 string. Okay, okay, let me do it first. Okay, so let's say, let me take an example that will help you to understand. So let's say I have got a string AAB. So how this internally works is, there is a, so this string has length equal to 3. Let me start with 0. So 0 and 2. Now there is a concept of read header. Okay, read header. So first, the first alphabet of this string will be scanned, and it will check if there is any transition for this input symbol. And in my final machine, okay, this is not the final machine, I'm just telling you the underlying concept. So it will first check the first symbol and it will check if there is any transition for that alphabet. And obviously it is DFA, so every state will be complete. So it will just keep on following the transitions, and at the end it will check whether the current state is my final state or not. If this is the final state, then the string will be accepted, otherwise the string will be rejected. Okay, so this is how it goes, and the read header will be forwarded to the next position and so on. It will go on like this. So what I was saying, that we are in Q1 means we have traversed first alphabet. We are in Q2 means we have scanned second alphabet. Okay, so here the condition is length 3, so we have to make another transition, and this is how we represent OR condition. So because there is, as I said, there is no restriction on the alphabet, so whatever be the input symbol, A or B, it will make a transition. And so we are in Q3 means we have accepted a length 3 string, and according to the condition it will accept this string. So this will be my final state. Okay, now step 2 is complete. Okay, because we have accepted the smallest possible string. now as you know, DFA is a complete system, so completing the system means in each state there should have one transition for each possible input symbols. So Q0, Q1 and Q2 are complete, but Q3 is not complete. We have no transition for A and B, so we have to make that. So in step 3, first let me just copy this step 2. Then, so this is my final state. Now any string that has length greater than 3, that will be rejected. So how to implement that? So I have discussed in my previous video that whenever we are in such situation, that we can assure that if, I mean, in that position, we can assure this string will be rejected. So in this case also, we can assure that if the length of the string is greater than 3, we can reject the string. There is no possibility that we can reach the final state from that state. So, and I have also discussed a concept called dead state. So how to implement dead state? We will make a new state. So this is just a conventional way. There is no restriction that you also have to use QD, and we will just add a self loop over here. So how this works is, for any string that has length greater than 3, from Q3 it will make a transition to QD, and it will just keep on looping over here, and it will that string will be trapped in this QD, because there is no possibility that string will reach from QD to Q3. There is no transition from QD to Q3. So when the length of that string will be exhausted, the current state will be QD, and as this is not the final state, that string will be rejected. So let me take an example. So as I said, this is a string of length 3. So according to the condition, this string should be accepted. So let's check. First, this alphabet will be scanned, and according to this transition, this will make a transition from Q0 to Q1, and the read header will be forwarded to next position. Again it will check another transition, so this will be forwarded to next. So what I want to say is, when the read header is at position 2, we are in state Q2. Okay, now I mean read header is at position n means we are at state Qn. Okay, so it will again scan this B and it will reach Q3. Now this length of the string is exhausted. So what is my current state? Q3, and according to our machine, this is my final state, so this string will be accepted. Now let's take another example where I will show you that a string of length greater than 3 will be rejected. So let's say any string, okay, A, let's say B, okay, length 5 string. Now first read header is at this position. So this will make a transition from here. It will scan this and it will make a transition from Q0 to Q1, and it will keep on scanning and making transitions. So this 0 position 1, 2, 3, 4. So when the read header will be at this position Q2, at position 2, as I said, we will be present at this state Q2. Okay, now it will scan this alphabet, and it will make a transition from Q2 to Q3. This will be forwarded to here. Again it will scan B, it will make a transition from Q3 to QD. Now it will scan B, and it will, as there is a self loop, so the next state will also be QD. This time the length is exhausted, so what is my current state? QD, and this is not the final state, so the string will be rejected. So this is how it goes. Okay, and yeah, so basically what we do is, we just keep traversing through or scanning through the alphabets of the string, and we just keep on moving the read header to the next positions, and we will keep on make transitions, and after following all the transitions, we check if the current state is final state or not. If that is the final state, then the string will be accepted, and in this case, as this is not the final state, so this string will be rejected. And this is how it works internally. Okay, so I think if you just follow these read header concepts and the mechanism I explained, I don't think you will encounter any problem related to DFA designing problems. Okay, so the next question is another type of this kind of problems. So now our next question is length of W greater than equal to 3, and this is my possible input symbols. and the last will be, as you can already guess, length of W less than equal to 3. So this will actually exhaust all the topics of this type. Okay, so first, step 1. Now just see, there is this equality, so this machine will also accept all these strings like the previous one. So all these strings like AAA, AAB, all these will be accepted by this machine also. So, and after all these strings, the other strings will look like this. So let's say A, then A, B, B, or B, 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 like this, and so on. Okay. Yeah, so step 1 is over. Now step 2. Step 2, we know we have to design the machine such that it will accept the smallest possible string. And in this case, smallest possible string means the machine will accept the string that is of length 3, because this is the minimum condition, right? So we know that to accept a string of length 3, we will just have to, from this machine, this is my final machine. So as you can understand that to accept a string of length 3, we'll just have to do till this step, right? Because this is the step, this step has been added just to add the condition that it will not accept any string that is of greater than 3, length greater than 3. So let me just copy this. So just focus on understanding the concepts. Okay, AB, then next state is again AB, Q2, AB, and Q3. So any string of length 3 will be accepted here. Now the next condition, that is it will accept all the strings that is of greater than 3 also. So how to implement this? Now think about it. If we just add a self loop over here, okay, so any string that is of length greater than 3, so the read header will be moving. I will just keep on moving the read header, and when the length of the string will be exhausted, what will be my current state? This Q3, and this is the final state. Okay, so I think I'm just making it very complex to understand, to make you understand. So let me take an example, and I think that will help you to understand it. Actually, I have just merged step 2 and step 3 in this state. So these adding the self loop should be in step 3. Okay, so just let me take an example. Let's say it's the same example like this one. We know that this machine has not accepted this string. So let's see that if this machine accepts or not. So A, and then B, B. Okay, 0, 1, 2, 3, 4. Now read header currently at this position, so it will make a transition from Q0 to Q1, and when the read header will reach position 2. So what will be my current state? Q2. It will scan A, it will make a transition from Q2 to Q3. This will be forwarded to position 3. It will scan B. There is a self loop, so the next state will also be Q3. This will be forwarded to this position. This will again scan B, and it will just, now you can understand, if there is more B's or more A's, it will just keep on looping over these final state or Q3, right? So when the length of the string will be exhausted, it will just keep on moving forward, and when the length of the string is exhausted, so what is my current state? Q3, and this is the final state, so this string will be accepted. So this is how it works. Okay, now the last question for today and the last type of this topic is length of W less than equal to 3, and same set of input symbols. Okay, so let's do this. So now you can understand there is also this equality, so we will have to copy the same machine again, as I said in my previous video. So this portion will be as it is in this case also. So let me just copy this. So I'm not just again explaining all the steps. So just let me copy first Q0, A or B, whatever be the input symbol, it will make a transition. Again A or B, another transition. Again A or B. Now Q3, and this is my final state. So it will accept the strings having length equal to 3. Now it will not accept any string that is of length greater than 3. Okay, so the concept is same as the first one. Here also this machine will not accept any string that is of length greater than 3. So the same idea, we will use dead state. Right. So what this machine does, this machine accepts all the strings of length 3 and it doesn't accept any string that is of length greater than 3. Now you have to implement the less than portion. Okay, so before that, let me just show you what my set of strings will look like. So first, less than equal to, so any string of length 0. So in we represent a string of length 0 using this epsilon symbol. Okay, this means a string of length 0. Now string of length 1 could be A or B. These are the two possibilities. Then AA or AB and so on, and then length 3, so AAB and so on. So my set will look like this. So this is string of length 1, 2, and this is string of length 3. Okay, now if we make the first state final state, what does it mean? It means any string of length 0 will be accepted. I mean, we have not accepted any input and this is my final state. So if epsilon encounters this state, so this state will accept this epsilon because this is my final state. Now you can realize that if I just make this state final state, so this will accept all the strings having length equal to 1. I mean, if A comes to this Q0, it will make a transition from Q0 to Q1 and this length is exhausted. So what is my current state? Q1. So A will be accepted. Then for AA, I have to make this Q2 final state, right? So for AA, this will be my last state and this is the final state. So this string will be accepted, this AA or AB. So any string of length 2 will be accepted here, any string of length 1 will be accepted here, and any string of length 3 will be accepted here, and epsilon will be accepted here. So this is how it goes. Yeah, so all the types are exhausted and I have explained in great detail. So okay, so stay tuned. Bye bye.